The story of oil refining didn't start with massive industrial complexes, but with lamp oil. In the mid-1800s, whale oil, the dominant fuel used to light homes and streets across the world, was becoming scarce and expensive. In 1859, Edwin Drake drilled the first commercial oil well in Titusville, Pennsylvania, and the race to find a use for the dark liquid that came out of the ground began almost immediately. Early refiners discovered that by heating crude oil, they could separate out kerosene, a clean-burning fuel that could replace whale oil in lamps. Everything else that came out of the process was considered waste and was often simply burned off or dumped. But as demand for new products grew and engines were invented that could run on the byproducts refiners had been throwing away, the entire industry transformed. What began as a search for lamp fuel became one of the most complex industrial processes in human history. To understand what refining actually does, you first need to understand what crude oil is. It isn't a single substance, it's a dense, dark mixture of thousands of different hydrocarbon molecules, chains of hydrogen and carbon atoms that vary enormously in size, weight, and structure. Mixed together in their raw form, they are largely useless. The entire purpose of refining is to pull that mixture apart and sort it. Once crude oil is pumped out of the ground, it travels through pipelines to a refinery, often covering hundreds or even thousands of miles. Before the oil can be processed, it goes through pretreatment. Raw crude carries with it a range of unwanted guests: water, salt, sand, and sediment picked up during extraction. If these were allowed into the refinery's equipment, they would corrode pipes, damage machinery, and contaminate the final products. After the contaminations are discarded, the next stage is fractional distillation, and it is the heart of the entire refining process. The cleaned crude oil is pumped into a furnace and heated to around 350 to 400 degrees Celsius, hot enough to vaporize most of it. That vapor is then fed into the bottom of a tall steel column, sometimes 60 meters high, called a fractionating tower. Inside, the temperature drops steadily from bottom to top. As the vapor rises through the tower to different hydrocarbon molecules, cool down and condense back into liquid at different heights, depending on their weight. Heavy molecules condense near the bottom, where it is still hot. Lighter ones travel higher before they cool enough to collect. Each level of the tower draws off a different fraction. Heavy fuel oil and bitumen settle at the base. Diesel and kerosene form in the middle sections. Gasoline rises toward the top. The very lightest gases, including propane and butane, exit as vapor from the very top of the column. Each fraction is piped away separately for further processing. What comes off the distillation tower is useful but not yet optimized. Refineries don't just separate crude oil, they also reshape its molecules to produce more of what the market actually wants. Cracking is the process of taking large, heavy hydrocarbon molecules that didn't rise high enough in the tower and breaking them apart into smaller, lighter, more valuable ones. In a process called fluid catalytic cracking, heavy fractions are exposed to heat and a catalyst, a substance that accelerates the chemical reaction, which snaps the long molecular chains into shorter ones that can become gasoline or diesel. Without cracking, we simply wouldn't have enough gasoline to meet global demand. But not every molecule needs to be broken. Some just need to be reshaped. Reforming rearranges a molecule's internal structure without splitting it, transforming low-quality gasoline fractions into the high-octane fuel modern engines require. Before any product leaves the refinery, the last remaining impurities hiding inside the fractions have to be removed. Sulfur is the most significant problem. It occurs naturally in crude oil and, if left in the final fuel, produces sulfur dioxide, a gas that damages engines and contributes to air pollution. In a process called hydrotreatment, hydrogen gas is forced through the fuel fractions under high pressure, reacting with sulfur compounds and pulling the sulfur out of the mixture entirely. Other contaminants, including nitrogen compounds and metals, are stripped out through similar chemical treatments, leaving each fraction dramatically cleaner than it was coming off the distillation tower. The final step before anything is packaged or shipped is blending. Pure fractions on their own rarely meet the precise specifications required for commercial products. Refineries blend different fractions together in carefully calculated proportions, then add chemical packages that further improve performance. Gasoline receives detergents that keep engine components clean and antioxidants that prevent the fuel from degrading in storage. Diesel receives additives that improve cold weather flow. Aviation fuel receives corrosion inhibitors and anti-static agents. Every finished product that leaves a refinery is engineered to a specific formula, not simply collected. And those finished products extend far beyond the different grades of fuel that most people picture. Gasoline, diesel, jet fuel, and marine fuel are the obvious outputs. But a refinery produces much more than what goes into engines. Liquefied petroleum gas fills the cylinders used in home heating and outdoor grills. Naphtha becomes the feedstock for plastics and synthetic fibers. Lubricating oils end up inside engines, gearboxes, and industrial machinery around the world. Bitumen, the heaviest residue from the bottom of the tower, is mixed with aggregate to surface roads and waterproof rooftops. Paraffin wax goes into candles, cosmetics, and food packaging. Petrochemicals drawn off during the process become the raw ingredients for fertilizers, pharmaceuticals, detergents, synthetic rubber, and thousands of everyday materials that have no obvious connection to a barrel of crude oil sitting in the ground. Click the video on your screen right now, and I'll explain another everyday mystery you've wondered about your whole life but never thought to look up.